In this tutorial, we're going to learn about the if function. Specifically, we're going to learn by understanding what is an if statement. Then we're going to learn about conditions utilizing the if statement, for example, the and the or. We will learn how to work with multiple if statements using a nested if. And finally, we're going to use an optimization of the nested if, which is using the ifs function. Let's get started. Let's learn about the if statement through an example. Let's say we want to classify somebody as a child, and the definition of a child is somebody who's 12 years old or less. So we would ask for the age of the individual and ask ourselves, is the age less or equal than 12 years old? If this happens to be true, we will classify them as a child. However, if this is false, we would classify them as not a child. In this example, we only have two options, child and not child. Let's work through this using spreadsheets. Let's work with the following spreadsheet. You can get a copy of the spreadsheet in the description below. Here we have two tables. The first table has the age of several individuals between 0 and 79 in ascending order. And in the second column, we want to add child or not child. The second table has the lowest age, the highest age in the group. The first group is up to 12 years old, and we're going to call them child. The second group is 13 years and above. We call them not child. And we have a chart that describes the if statement below. Let's start with the first example. Let's make this an equal. We're going to select the age and ask ourselves, is this less or equal than the high age? In this case, it's 12. We're going to make it an absolute reference using F4. Notice that it is true, and we're going to copy this all the way down. The first three ages are true, and the last ones are false. We're going to work with two main assumptions. The first assumption is that all the numbers are positive. The second assumption is that all the numbers are going to be integers. So for example, we're not going to have an age of 12.1 years old. In this case, 12.1 would be false because it's above 12 years old. Now let's work with a second way of writing the same statement. We can say equal the age is strictly less than 13 years old. Let's make the 13 an absolute reference and copy this all the way down. Again, we obtain the same results where the first three values are true and the others are false. Notice that in this case, if we type the first age as 12.1, it remains true. But we're going to work with the assumption that all numbers are integers. Let's work with another case. Let's start using the if statement. Notice that the if statement requires three parameters. First, a logical test, then the value if it happens to be true, and then the value if it happens to be false. Let's start with our logical test of saying, is the age less or equal than 12 years old? And we're going to make this an absolute reference. If it happens to be true, we're going to label this as child. So we're going to write in the word child. And for the false statement, right now we're going to leave it blank to see what the default is. Now we can see the first case, we correctly label this as child. And if we copy this to the bottom, we see that all the other options are just plain zeros. Now, one of the reasons we don't want to hardcode the word child there is that if we want to modify that word to something else, we have to manually do it. Another way is that instead of typing in child, we can select child and make it an absolute reference. And let's copy this all the way down. So if tomorrow we want to replace the word child with infant, we only update one place and automatically the rest of the spreadsheet is updated. Let's undo this. Now let's rewrite our if statement. Let's delete what we have and start by saying equal if. Again, we're going to put our condition of the age being less or equal than 12 years old as an absolute reference. And we're going to leave the true value as blank and the false value as not child. Let's make that an absolute reference and copy it all the way down. Notice that the opposite happens. For the true statement, we're going to obtain zeros, while the false statements, we obtain not child. Now, this is not what we want. What we want is child and not child on each row. So let's rewrite the if statement. We're going to say equal if the age is less or equal than 12 years old as an absolute reference. And if so, we're going to label it as child as an absolute reference, otherwise as not child as an absolute reference. Let's copy this all the way down and see what we obtain. Here we have the results as we would expect. And this matches the graph on the right. We can also select our data and add conditional formatting. So for example, we can say if the data is equal to the word child, then let's customize it and change the color of the font to blue. We can see now that child has been labeled in blue, and we can add another conditional format where if the data is equal to not child, let's customize the format to make the color of the font purple. So now we can see that childs are in blue and not child are in purple. Let's work with our first condition with the if statement, the condition of and. In this example, we want to determine if somebody is a teenager. To be a teenager, they need to meet two criteria. First, their age needs to be strictly greater than 12 years old, and their age also needs to be less or equal than 19 years old. If they meet both of these criteria, then we can label them as teen. However, if they do not meet both of these criteria at the same time, then we're going to label them as not teen. Notice that in this case, we still have two options, teen and not teen. Let's work on the spreadsheet example. Let's look at the changes in table 2. Less than 12 years old is not a teen. Between 13 and 19, they're labeled as teen, and above 20, they're not teens. Notice the graph that indicates this. Let's start with the first condition. Let's work with the first column to determine if the age is greater than 12 years old. Let's make the 12 an absolute reference. Notice that in the first row, it's false. Let's also make the second condition if the age is less or equal than 19 years old, and we're going to make that also an absolute reference. Let's copy these two columns to the bottom. We notice that in the first column, anybody who's 13 and above happens to be true. And in the second column, anybody who's 19 or below happens to be true. What we're looking for is for the areas where both columns happen to be true. This is our teenager range. For this, we're going to use the AND function, which is going to be true if both of these values in the rows happen to be true. So we can see that in the first case, it's false because only one value is true. And the ones in the middle happen to be true because those meet both of the conditions. Let's test the boundaries. For a 12-year-old, it's false, 13 is true, 19 is true, and 20 is false. Now what we need to do is implement the if statement outside of the AND. And we're going to say if both of these conditions happen to be true, then we're going to label them as teen, and we're going to make this an absolute reference. Otherwise, it's not teen. So we're going to select one of the not teen values, make it an absolute reference, and see what the results look like. Notice that the conditional formatting is already implemented. Notice that the middle ones, 13, 17, and 19, are highlighted in blue because they are teens. In this example, we're using two helper columns to include inside the if function. We can also put everything nested inside just one formula. It is up to you to decide if you want to use the helper columns or not. I recommend using them because it's easier to debug the issues. Let's try putting it all into one big equation. We start with the if and then an and then we select the age greater than 12, make it an absolute reference, comma, the age less or equal than 19, and we make that an absolute reference as well. If this happens to be true, we're going to label it teen, make it an absolute reference. comma, otherwise not teen, and we make it also an absolute reference. Let's copy this to the bottom, and we obtain the same results as before. Let's now try to solve the same problem as before using the OR condition. In this case, we want to determine if somebody's age is less or equal than 12 years old, or if somebody's age is greater than 19. If one or the other condition happens to be true, we're going to label this person as not teen. However, if they happen to be false, we're going to label them as teen. Notice that in this case, we still have two options, not teen and teen. Let's make this work using spreadsheets. In this spreadsheet, we see the chart that shows the opposite as before. Anybody who has less or equal than 12 years old or greater than 19 is not a teen. Everybody else will be labeled as a teen. In this first column, we're going to make this equal to the age less or equal than 12 years old as an absolute reference. So these are people who are not teens. Similarly, we want to determine if the age is greater than 19 years old and make this an absolute reference. Let's copy this all the way down. What we notice is that the people who have been labeled as true either on column 1 or 2 are the people who are not teens. And everybody who has false on both columns happen to be teens. We're going to use the OR statement, which will be true if at least one of the values happens to be true. So we're going to copy the statement all the way down, and we notice that it is true for everybody who's not a teen and false for everybody who happens to be a teen. So we're going to add the if statement outside of the OR statement. And if this statement is true, we're going to label them as not teen. We can select either of the not teens and make it an absolute reference. Otherwise, we're going to label them as teen, make it an absolute reference, and we're going to copy this all the way down. Notice that the conditional formatting is already implemented and the teens have been labeled correctly. We can also put all the equation into one statement without helper columns. Up till now, we have worked with simple if statements that produce two results. Let's look at a multiple if statements with more than two results. Let's start again by asking, is the person's age less or equal than 12 years old? If true, we will label them as a child. And if false, we're going to ask a second question. Is their age greater than 12 and less or equal than 19? If that is true, we're going to label them as a teen. Otherwise, we're going to label them as an adult. Notice that in this case, we have three possible options. You can imagine we can expand this even further by splitting the adult into senior citizens and so on. For now, we're going to remain with only three options and move this into the spreadsheets. In this spreadsheet, we have updated table 2 to have now three conditions. Anybody less or equal than 12 years old is a child, between 13 and 19 is a teen, and 20 and above is an adult. And we can see the new chart being updated with child, teen, and adult. We have three helper columns that we're going to use. The first column is going to determine if the age is less or equal than 12 years old, basically if they're a child. Let's make it an absolute reference. The second column, we're going to use the AND statement to determine if they're a teen. So the age needs to be greater than 12. We're going to make this an absolute reference, comma, so and the age has to also be less or equal than 19 years old. And we're going to make this an absolute reference. Finally, for the last column, we want to determine if the age is greater than 19 years old. And we're going to make this an absolute reference. Now we're going to copy this all the way down. What we see is that the values on column 1 that are true are the child. The values on column 2 that are true are the teen. And the values on column 3 that are true are the adults. Next, we're going to use the if statement. We're going to use the nested if statement in this spreadsheet in a different approach on a different spreadsheet. For this, we're going to type in if. We're going to select the first column. So if that is true, we're going to label it as a child. We're going to make this an absolute reference. Notice that the next value should be the false condition. So given that there are more than two conditions, we're going to add a nested if, so another if statement inside of this. We're going to put the second column, and if that happens to be true, we're going to label it as a teen. Now, if that happens to not be true, here is where we're going to use the adult label, which we're going to make an absolute reference. Let's close all the parentheses and copy this all the way down. Notice we already have the conditional formatting. We can see the child, the teen, and the adults properly labeled. We can notice that the last column was not utilized at all. It is here for reference, but it's actually not needed because the last statement says if everything else fails, then we're going to make the label equal to an adult. Nested ifs functions can get very messy. Therefore, there's a better solution, which is using the ifs function we're going to learn next. In this spreadsheet, we're going to do the same calculation, but in this case, we're going to use the ifs function. Notice that the first three columns have already been pre-calculated. We're going to type in ifs, and we can see that we require a logical test and the value if true, and we keep repeating this. So we're going to select the value of the first column, and if that is true, we're going to select child as an absolute reference. Then we select the value of the second column and teen as an absolute reference. And finally, we select the value of the third column and adult as an absolute reference. Now we can close the parentheses and we can copy this all the way down. And here we can see that we have separated child, teen, and adults. Now notice that the last column was used in this scenario, but we actually do not need to use it. There's a little trick we can use for the remaining values. So again, let's start with the if statement. Select the first column, label it as child. Now let's select the second column and label this one as teen. And then we're going to type in the word true. And true means a catch-all for anything that has not been included already. And we're going to label that as adult. In this case, we can close the parentheses, and anything that did not meet the child or teen criteria will be classified as an adult. There is an optimization we can apply to our logical if statements. Let's look at the example. If somebody has an age less or equal than 12, we can classify them as child. However, in the next case, we can just ask, are they less or equal than 19? And remove the condition if they are greater than 12 years old. The reason for this is that everybody who's less or equal than 12 years old has already been classified as child, and they no longer belong to the if statement. So whoever is remaining for this second question are people who have more than 12 years of age. These folks who are less than equal to 19 are classified as teen, and finally, the remaining people will be classified as adults. Notice that there's a logical order starting with first asking who's less or equal than 12 and then the 19. As a result, we have the three options. So let's model this with spreadsheets. Here we're going to model an optimized way of using the if statement. We need to be very careful to make sure we understand what we're doing. The first column, we're going to determine all the ages that are less or equal than 12 years old. We're going to make this an absolute reference. Notice that in the second column, we're going to determine everybody who's less or equal than 19 years old. We no longer are looking for the condition of greater than 12. Let's copy this all the way down. We can see that the first few rows, both columns have true. The middle rows, only the less or equal to 19 is true, and the last few rows, they're all false. Now let's write our ifs statement. If the first column happens to be true, we're going to label this as a child. Let's make this an absolute reference. Now, if the second column happens to be true, which in this case it is, we're going to label them as a teen. But notice this condition is not going to happen if the first column happens to be true. All the individuals who are true in the first column will be labeled as child, and we are never going to test the second condition. Then we're going to add the label of true towards the end, and for everybody else, they're going to be labeled as adults. Let's copy this all the way down, and we can see that everybody who is true in the first column was labeled as child. Everybody who is only true in the second column was labeled as teen, and everybody else was labeled as an adult. Previously, we mentioned that with this new optimization technique, the order does matter. Let's look at an example. Let's say we first ask if the person is less or equal than 19 years old. If so, we're going to label them as teen. However, if this is not the case, we're going to ask a secondary question. Is this person less or equal than 12? If so, we're going to label them as child. When we think about this carefully, we notice that this option will never occur in reality. For example, a 5-year-old in the first question would have been labeled as teen and never reach the second question. Therefore, the order of these two questions makes a difference. Everybody else who was not labeled as a teen or a child will be labeled as an adult. In this case, we notice that we have three options, teen, child, or adult, but the option of child in practice will never occur. Let's see how this plays out using spreadsheets. Let's work with a different order of operations. Notice that our first question is going to be if the age is less or equal than 19, followed by the age less or equal than 12. So let's start with our helper functions. Let's see if the age is less or equal than 12 as an absolute reference. And let's also see if the age is also less or equal than 19. And we're going to make this an absolute reference. And we're going to copy this all the way down. Now let's use our ifs statement. In this case, we're going to start with the question, are they less or equal than 19? And if so, we're going to label them as teen. Let's make them an absolute reference. Then we're going to ask if they are less or equal than 12, and we're going to label them as child. Now everybody else, we're going to add a true. We're going to label them as an adult. Let's make this an absolute reference. Let's close the parentheses and copy this all the way down. We can see from these results that the children have been labeled as teens. In other words, the order of the operations do matter, and we need to be careful with this potential pitfall. We can also solve these types of problems using lookup functions, and there are extensions like the COUNTIF, SUMIF, AVERAGEIF functions, and so on. If you enjoyed this content, please subscribe to the channel and let us know in the comments if there are other topics you would like me to cover.